going to do is I'm going to use STM8 as with the TM16 and 37 um, 4-digit 7-segment display. So I'm going to use the 4-digit 7 display interfacing with the STM, and for I found this repository from Indigo 6 Alpha very useful. So I would be like to translate this repository for the Arduino. So today I'm going to code in the Arduino. Um, so make sure the SCM is selected. I don't know if you are able to view my text size. Um, I'm pretty new to this live streaming. I want to try this feature, so maybe I need to adjust things. So bear with me and let me know that you want you would be able to see this or not. Anyways, so what I'm using is okay. So one thing that we need is this one and the STM blue pill um, Arduino pinout. So yeah, this diagram. So this board we are using, and we need this pinouts. Okay, um, let's dive into the code. Here you can see, first of all, we have some header files. It has some options for the clock. Um, in the Arduino, we don't need this kind of clock configurations, so I would just pass that. Next is the GPIO. The Arduino itself have this GPIO handling, so I would pause that as well. And one more thing is TM1634. Yeah, we need that. I think I need some kind of online notes taking for this. And note. Yes, I think this note taking would help. So let's try out some kind of notes that we need. Okay, so we have this file, and here we have the function of tm start. Let's copy that. Then we have tm stop. Yes, we'll be using that maybe. Uh, I muted due to my environmental noise, and I beg your pardon for that. Okay, so TM1637. Okay, so this is a table which we definitely need that. So I will just copy that as it is, save this file. I would not name it for now. Let's skip it. I don't know if this would be a file or I need to create another file. So yeah, maybe I would properly name it later on. And for the naming conventions, for now, I would stick with the uh, repo I'm copying the code from. So yeah, let's recreate this function as well. Maybe we need that. So let's make it use of the delay function. So yeah, we have the two now. What is the next thing? We need a clock pin and the initialization function. For the initialization and the start thing. Okay. Okay. So I need to mention one more thing here is that we need two pins to communicate with the TM1637 chip. Is the DI. So I don't know what name it is giving to that, the B clock B data or some else. I think I chose the wrong time to go live. Okay, the TM start function, delete that. I think we don't need a static here. Let's remove that for the sake of the simplicity. And we also don't need to keep track of this one. Let's decide which pins are we using. Um, how about using these are the analog pins, so I would not go for that. This one is for programming. I would not go with that either. This one is for I2C, so no option. These are the UART pins, so not that. And what we left, the D0 and D1, I think these two pins would work. Maybe some different pin. These are the analogs, SWM, the D5 and D13. But these could be the best use of the PWM pins. So what option do we have now? Okay, let's say I want these two pins to be next to each other. So okay, I would sacrifice lock pin and D5 and D6 would do the trick. So let me connect my pins to the blue pill board, and because I'm using the 3.3 pin, I would connect the VCC to the 3.3. I'm not sure if this will work or not. I have to test this out. Okay, so 3.3 and the ground. I'm not showing this one on the camera. I know if I can. Okay, so I am actually doing this to the ground. Okay, so if you are able to see this, I don't know. Yeah, so I connected things like that. If they are visible, I'm not sure. And the next thing, what about the D4 and D5? Where are they? Um, the D4 and the D5 are these two pins. Yeah, no, I would not go for that. I will choose. What about these two? Okay, stick with that. No, we choose the C4 and C3. So let's go for that. If you're wondering, these are the pin numbers that are printed on the board, and these are the alternative macros for these pin that you could use in your Arduino. So, but these are the actual. So, for example, if we are using the D5 and D6, these are two digital pins, but the actual pins are port C and the pin number 3. Similarly, port C and 4. So if you are using the STM8 standard peripheral libraries, you may be using the GPIO-C and the pin 4. GPIO C4 and GPIO C5 would work if you are using the thing in the standard peripheral libraries. And the one more cool thing about the Arduino coding is that you could use the standard peripheral libraries right into this sketch. So basically, this sketch is included the GPIO the GPIO standard peripheral libraries for you, so you can use them. So this although this function is from the repository we are copying the code from, so this is not the standard peripheral function. But if you are familiar with the concept of the ST links, the ST's standard peripheral libraries, so these function you can use that. Basically, the ST provide the standard peripheral libraries. So if you go for the STM8 standard peripheral libraries, you have a link from the st.com, and here you can download your standard peripheral libraries. So this one is pretty similar to the STM32 standard peripheral. So if you are familiar with the concept of the standard peripheral library, it is basically the standard peripheral libraries provided from the STs. So you can access all the libraries, all the peripherals of the microcontroller under this similar API. So you can search that from the STM8S, I guess you need to put that, and standard peripheral. I don't know. Let's see what this pop up. Yeah. So this is the STM8SA standard peripheral library. So you can download that if you are familiar with the concept. But the good news is it is already included into the Arduino. So all your environment is already set up. So you don't need to include any other thing in that project. Okay, back to our code. What we are going to do is to use our what were we doing before? I just forgot. Okay, we were selecting the pins, so we were using the D5 and the D6. I'm putting the randomly pins. I don't know which one go for which. Not the which. The clock and the DIO. Okay, so the purple wire is for the purple one is connected to the clock. So I am going to connect the purple wire on the, which one was that? C4 and C3. Okay, C3 and C4. So we need to leave these two pins from the downside and connect. Yes, I just connected. So I connected C3 to the DIO. So I need to make sure that I put the right macros into my code. So I prefer the defining things, and DIO is connected where? So the DIO is connected to the C3, which is D5. So I would say 5 and define the clock, and I connected the clock to the D6. So I would say 6. That's all for that. So the next thing I need to do is to create, um, let's start from the initialization function, which seems pretty simple. Okay, so I would just say, okay, um, I would just say void. I don't need anything. I don't know why this repo return. I don't have to figure that out. So let's say pin mode. We can use the Arduino style of functions here. That's pretty cool. DIO. What? Uh, we are going to make both of these pins as an output. So put it output, pin mode, clock as an output, DIO and clock both are output, and we are setting the clock to low and the data to low. So that's digital write, clock as low, and digital write, DIO to the low. Yeah, so that's pretty all for the initialization of the segment, I guess. It seems easy, but believe me, it's not. It's just a headache. Move on. So the moving on, we have a start function. Let's create this one as well. And yes, we already copied the code for the start function. What are we? We are setting the pin high of the data port. So let's do that. We have a digital write function for that. We can DIO and high. So that's pretty all for this line. We already done that, so remove that and digital write the clock and high, and clock delay. I don't know where this macro came from, so let's figure that out. What? They have a 0 as the clock delay. That's insane. So basically they are giving the 0 millisecond delay. Okay, if they are, let's put a 1 millisecond delay here and remove that. After that, we need to put the pin low. So the data port I think this still, my bad. This sounds is not coming slow. So um, let's, okay. So let's put this pin low, and because we have a pin low function here, so what we are gonna do, we can replace this millisecond delay to the microsecond, I guess. I don't know if we have available this in the STM8 as well or not. So let's try it. Let's put some 100 microseconds delay. So I don't know if this function works in the STM8. We will figure it out together in today's stream. After that, what we need to do is to put the pin low. So digital right, and the DIO will go to the low. Because we are pulsing the DIO pin, so it seems a little bit okay to put this one together. So it seems we are pulsing the DIO for the 100 microseconds and putting it back to the low. As you may know that we put in the initialization both of pins to low. We did the clock too high, then DIO too high, then 100 milliseconds of the delay, microseconds delay, and then put the DIO to the low. I know what will happen to the clock, so maybe we'll figure that out, or we had to tackle with it. Um, Actually, I'm also not sure either this repository is actually working or not, but it seems promising. I know how. It just click. So we'll see if this will work or not. We need to fix if something goes wrong. So we have a function as well. We need to um, implement that as well. I know it's pretty bad to put all the code in your sketch, and I'm not actually doing a good SE practices, so that's pretty seems bad smell. But stick for it right now. We'll figure it out later on. First of all, I try to make things works as with the as small coding as possible. So here it says to stop the TM1637 chip. Okay, I don't know if I already mentioned it or not, but it just came into my mind, so I like to mention that. Basically, this module is using the TM1637 chip, which could handle, I think maybe approximately 6 digits at a time. So, but this module comes with the 4 digits. So basically, we are what we are actually dealing with is this chip. The chip is called the TM1637. So coming back, here we are going to stop. For stopping, it says that we need to clock low. So it is pretty simple. We will just write the clock pin and to the low. So this thing done. And because we are delay microseconds and 100, what about the 500? We'll see if it is too slow or not. Actually, I wrote this library for the STM32 along, so I didn't remember anything. If we get stuck somewhere, maybe I will try to look for that code. But for now, okay, I'm switching off the camera. Um, okay, for now, let's come back and remove this delay function, and we need to put data to low. So that thing we are going to do is digital right DIO to the low. Cool. So we can safely remove this one, and we can copy this line, put it, and safely remove that as well. I think they did a pretty good job by declaring this delay globally. So maybe I should do that as well. Um, cool. So now I can use this macro replacing everywhere. So it is better doing it now instead of later. Okay, then put the clock back to high. I think it's after the delay. We need to put the clock back to high. So digital write clock to the high, and then we need to put the delay. So let's put it here, and let's keep the command. Uh, we did both of these, I guess, so we are good to remove these lines. Then finally it is putting the data to high. So finally we can do that right to the high. So this function is done. So we have a stop function, we have a start function. I think I should remove this one as well. We have initialization function, so definitely we are going to use this initialization into our setup function. So let's put it here. We need to call that, and we had already implemented the start function while we have this down below, so let's remove that as well. So now we have initialization function, start function, and stop function. Let's see what we need to do more. We have an acknowledge function. Okay, so we need to seek for the acknowledge somehow. I don't know. So let's copy that and put that here. Read acknowledge, clock to low, um, digital write, clock to low, and data as in. Okay, so what we are doing here? What line? Setting low, and then a little bit delay. So microseconds, and for the clock delay, and set pin high. The clock is high again. So the digital write clock high. This is a clock pulse, complete pulse. Then the delay again. Delay microseconds, clock delay. So uh, let's put this command here. Clock low, clock high, and then clock low again. What? What about this one? Why are we returning this? I don't know. So let's void it, because I don't. It make no sense. Why are they returning the acknowledge if they are not reading anything? Why to return something when we are not reading something? Data as input, but we didn't make the data as input. Did we end the function? Let's figure this out. We put the clock to the low. No, we didn't do anything. I think we need to make the data as input here to properly read the acknowledge. Yeah. Okay. Let's stick with the code and put the clock low. Let's remember the to do that make sure we need or do not need DIO read. So we are safe to pass these two lines as well. We are done with that. The next thing we are going to do the write byte. Okay, that seems a little bit of complicated thing. Let's see if we can handle that. Oh, that seems a lot of work. Okay, GPIO set pin low. Make the clock low. Digital write clock low. Remove that. Data high. Digital write DIO high, else put the data low. Digital write DIO low, and a little bit of delay microseconds, the clock delay, and finally clock high. So digital write clock high, and the delay microseconds for the clock delay, and we are safe to remove this one as well. So that seems pretty promising. I like to wrap them under the brackets and little one separation. So basically what it is doing, it is checking the last bit. If it is 1, it will simply write a high to the data pin. If it is not, there's 0, and then rotating the byte, incoming byte. So that's way it convert the parallel to serial and write the whole byte onto the one line. And the next thing, we have one more write function. It's a pain, that many functions. pdata blan. Oops. It is ending equal and the stop. Let me think. Are we doing something with the back acknowledge and equals? No. So why to get acknowledged then? Let's remove that as well. Let's remove that. Let's see if we are missing something. Let's try to compile the code. Meantime, let's come back here. We have a set brightness function. So we have either 0 or some value. I think we can simply copy that function. We don't need to write anything. The copying the code would works. Show digits, that's the main function which will actually display the digits. I think we already had written pretty much the code we need to use this one. The compilation process is taking too much time. We have C digit to segment array. Yep. So all we need to do is to wait for the build, and then we need to build again. It is a lot of wait. Meanwhile, let's see how we are going to use them in our main.c file. So it will initialize the GPIO. Are they doing that in the TM1637 init function? Like this? First of all, they are initializing the clock. The Arduino do that for us, so we don't need that. After we have okay, so the show digit, they convert the everything into the string and then printing it. So they are basically using the the string. So they are sending the string. Okay, so we can try that. We can. They are making an array of characters. So let's grab that, put it here. Let's try to compile it again meanwhile. So we'll just make sure that we are not getting anything. And they are putting in the setup, the brightness. And finally, they are printing the digits to the controller. And we can do that in setup as well. What we have in the SC's temp, let's make it here 1 2 colon 3 4. I don't know if this will work, so let's see if it works. I'm just getting a hint that maybe I need to look for some other code for displaying the values. We need to debug the code. I'm just getting the vibes. I wish it would be wrong. So I'm plugging in my ST-Link into and uploading the code and see if it works or not. I'll show you if it does. So wait for the compilation process to complete. Meanwhile, okay, I'm glad we had 3 likes already. Thank you for the likings. Okay, whoa, it actually worked. See this? Are you able to see this? Is it? I don't know which orientation it works. Cool. We have that. Let's unplug, replug, and see it. See? You may be seeing it inverted, but it actually works. Let's try to change it to 6 7. STM8 we can't pass more than that. Let's wait for the upload process to complete. Oh, it works. So I think our job is done for today streaming. Um, it means that the acknowledge actually didn't do anything. I'm not aware with the data sheet of this code. I just use this library and translated it into the Arduino version. I really thank Indigo 6 Alpha for writing this, and I just did it for the educational purposes. I don't know if we have some kind of licensing issues or not. So I just want to give the bundle of thanks to this person. Let's see how many repo he owns. Okay, I didn't notice. Um, oh, it committed in the 2021 and have 2 followers. Let's give a little bit follow to this person, although it is not working online. But oh, this library is written 4 years ago. I don't know if this person will accept this one or not. But yeah, that's all for code, and try to make our own version of it, because we have a lot of functions that we can use in the Arduino already. Maybe in the next sitting, I would try to write library just like the Arduino libraries we have. And this stream is already 43 minutes. So thanks for joining, and um, if you like the video, subscribe. If you don't, leave a comment, and thank you for your time. I need to see how to end this stream. Whoa. Okay, how to end this stream? The live option. Poop. Puke. It's my first time streaming.